welcome to Math 126, Chapter 1 review. Most of the comments as of this morning indicated that you understood the material, so I hope that's common across the board. There was a few comments about some questions. This first one has 4 questions, but not any instructions on them, so I'm going to assume I know what the question is on each one of these, and I'll work them through. I'm also not sure where they came from. I looked through the homework and I couldn't find these particular problems, so at any rate, we'll work through them. They are problems that are similar to what we've been working on, so we'll run with it. But this first one, I'm assuming they want you to simplify, so that's what we'll do. I've got a complex fraction with a difference of 2 fractions in the numerator and then just an x plus 2 in the denominator. So in order to do anything with this, I want to combine these 2 fractions in the numerator, and to do that I need a common denominator. So I'm going to get rid of this real quick so I can work. I'm going to multiply this one on the left by the x minus 2. Both top and bottom. I'm going to multiply the one on the right by x minus 1. Right. So when I simplify this, I'm going to have everything is still over x plus 2. But in the numerator, I can combine this into a single fraction that's now over x minus 2 times x minus 1. Because it's this stuff is over that, this stuff is over that. So I can just combine it. And what I'll have is the result of this FOIL, right, minus the result of that FOIL. So let's write these out. I've got x squared plus 2x minus 2x, and then minus 2 times 2 is minus 4. And then minus the result of this FOIL, so whatever I get out of this, it's going to be minus that. So that is x squared minus x minus 3x and then plus 3. Right? So there's some simplification I can do right off the bat. Plus 2x minus 2x can disappear. Right? This minus 3x and minus x I can write as minus 4x if I wanted to just combine that real quick. So I'm going to take this negative and distribute it through here. So everything else here, I've got this x squared, the 2x minus 2x disappeared on me, so minus 4 minus x squared plus 4x, and then minus 3. That is over this x minus 2 times x minus 1, and that is all over x plus 2. Okay. If I simplify a little bit more up here, this x squared and minus x squared are going to cancel each other out. And then I have 4x minus 7 is left over. That's all over this x minus 2, x minus 1. And that's all over this x plus 2. And it's weird at this point because we have this fraction now just over an x plus 2, but I can call that x plus 2 over 1 and treat it like now it's a fraction over a fraction. Now that I have this, I would simply flip and multiply. So I'm going to write this up towards the top. Give myself a little space to work. I have 4x minus 7 over x minus 2, x minus 1, and that's all over x plus 2, which I'm going to call over 1. So this is the same thing then as 4x minus 7 over the x minus 2 times x minus 1 times this flipped, so 1 over x plus 2. Right? And now that I'm multiplying, there's nothing to simplify. 4x minus 7 is not going to simplify with any of these. So my final answer then is just that 4x minus 7 over the 3 factors of x minus 2, x minus 1, and x plus 2. And that's it. The next one is 2 over the cube root of 5y. And again, I'm assuming that we are trying to rationalize the denominator here. So we've talked about rationalizing the denominator. If I have something like 1 over the square root of 2, I multiply this by the square root of 2 over the square root of 2, because the square root of 2 times the square root of 2, there's 2 factors under a square root, it pulls it out, it's no longer a square root, it gets rid of the square root, and it's a rational number. I want to do the same thing here, but if I'm under a cube root, 1 factor is not going to cut it like it did down here. I have 1, and if you think about this, a square root is an index of 2. That means I need 2 factors of 2 in order to pull it out. Here I need 3 factors of 5. I have 1, I'm missing the other 2, so that's what I multiply it by. It has to be the cube root, but I have to have 2 factors of 5 here. That's 5 times 5, that's 25, right? I also have to have 2 factors of y. I have 1, I need 2 more to make 3, and so that's a y squared. And so of course I have to multiply that to the top as well. Right? 5, another 5, and another 5 is 3. 3, that's 3. Math is hard. I've got 3 factors of 5 though I can pull out of the cube root as a 5. Same thing here, I've got a y, another y, another y, that's 3, boom, that many. I can pull that out of a cube root as just a y, right? And then the top turns a little bit ugly, but it's just 2 times that cube root of 25y squared. And that's rationalized. The denominator is rationalized, which is, again, I'm assuming what the question was wanting you to do. Good. Let's look at this one. I've got 1 over x squared plus 5x plus 6. And again, I'm assuming here that the instructions are to find the domain. Because that's what I would ask for this expression. And so what I'll do is factor the denominator. That denominator is a quadratic. Turns into x plus 2x plus 3. And so to find the domain here, my denominator can't be 0, which means that x plus 2 can't be 0. Otherwise, if it is 0, 0 times anything is 0, and I'm in trouble. Likewise, I can't have x plus 3 equal to 0. So I have 2 issues here. I would subtract 2 on both sides here to find that x cannot be negative 2. And I would subtract 3 on both sides here to find that x cannot be negative 3. That's my domain, and if you think about what this looks like, here's 0, there's a negative 2 here that's an issue, and there's a negative 3 here that's an issue. So it's all of these numbers. It can be the numbers between negative 3 and 2, and then it can be all of these numbers as well. It can literally be anything except these 2 numbers. And so to write that in interval notation, that would be negative infinity up to negative 3, excluding it, union, the exclusion of negative 3 up to negative 2 also excluded, and then union that again with negative 2 to infinity. If you note, there are indeed 3 intervals. Here's the first one, here's the second one, and there's the third one. So it's 3 unions. Well, 2 unions of 3 intervals. Good. All right, and then the last one, I'm assuming is to solve. Again, this is my assumption. This is the question I would ask you if I gave you this problem. 4 over x is less than x. very tempting to try to just multiply x, but then you have to break it into two considerations. If x is positive, I can leave my function how it is. If it's negative, I have to flip that inequality, but then also make sure that it's negative in the end or positive in the end, and I don't want to do that. So instead, what I'm going to do is use the fact that I have the the addition principle that's still given to me, and I'm going to subtract 4 over x from both sides. That gives me 0 on the left, which is typically what I want, and then x minus 4 over x on the right. And if you don't like it on the right, you could have subtracted x as well. It doesn't matter, right? What I can do though is call this x over 1, because that's the same thing. And then I can multiply the top and the bottom of this x over 1 by x, so that I have a common denominator. That leaves me with x squared over x minus 4 over x being greater than 0. Right? I do that because now I can combine this into a single expression on the right-hand side. 0 is less than x squared minus 4 over x. Right? And if it's a simple fraction, all I have to do is consider the zeros of the numerator, the zeros of the denominator, and see what happens on each one. This x squared minus 4 is the same thing as x plus 2 times x minus 2. So it's this expression that should be greater than 0, right? And of course, I'm going to have zeros at negative 2 and 2, and then an asymptote at 0, because I can't divide by 0. So pictorially, I have 3 places of interest. At 0, I'm going to write an open circle, because it's not equal to 0 at 0, it's an issue at 0. You're dividing by 0 at 0. But I do have the zeros at negative 2 and positive 2. Right? And that cuts me into 4 different intervals. And I just test each one, right? It'll either be true or false in each one of these. So I'll throw in a number like, say, negative 3 perhaps. Right? And I can plug it into this one, or I can plug it all the way back up into the original one if I want to. Let's do that. I'm going to give myself some room here just to work. I'm going to go all the way back up to the original inequality and plug in negative 3 and simply see if I get a true or false statement. So that is, I get 4 over negative 3 is less than negative 3, right? But that's negative 4/3 is less than negative 3, and that's not true, because that's negative 1 1/3, which is certainly not less than negative 3. Negative 3 is more to the left. So this is false. I'm just going to write an X for false. I want to try a number in between negative 2 and 0. I'll throw in negative 1. And really all I have to do is this, right? Negative 1, negative 1. Negative 4 over negative 1 is the same, 4 over negative 1 is the same as negative 4. Is that less than negative 1? That's true. This is definitely true, so check mark it there. That's true. Check a number like 1. If I plug in 1, now that's not negative, which means that's not negative and that's not negative. 4 is less than 1, that's false. And so, not true here. And then I'll plug in, say, 3 over here and see what happens there. It gives me 4 over 3 is less than 3. Well, that is true. And so it does solve over here. And so my interval here is where it solves, and it's a strict inequality, so I can't count where it's 0, right? Because that's not true. But between negative 2 and 0, so that is negative 2 to 0, unioned with negative 2, that's not a negative, that's a 2, 2 to infinity. And that's my interval. And again, I'm assuming that the question said solve for x. I hope it did, because I don't know what else you would want to do with that inequality otherwise. Anyway, hopefully that was helpful. Again, I don't think any of those problems came from our homework. I might be wrong, I might have looked at the wrong thing, but hopefully this sheds a little light on some of the material that we've been doing. Get in there, take your test 1, and good luck, and I'll see you guys for chapter 2.